So we started last class, or last kind of lesson, with looking at a way of describing the line that dealt with slope and y-intercept. Today we're going to take a look at a different one. This is called slope point form of the line. And so we're going to be taking a look at how do we represent a line, or how do we describe a line using a different type of equation. Now, in a little bit of review, one way to create a linear function of a line is, again, what we called slope-intercept. Using the slope and the y-intercept. Okay, and we call it slope-intercept form, or we can also call it graphic form. Okay, because it's nice and easy to graph, and it's fairly straightforward. The problem is when the y-intercept is not always a nice number or possible to find, and that is then a case where we're going to have to use a different way of coming up with a line. So let's go through again a little bit of review here. Let's describe this line right here. First things first, we want to try to find what is the slope of the line. Okay, and again, slope is just rise over run, and we have 2 points here. This point right here, which is at -6, +4, and this point right here, which is at +3, -3. And so we're going to draw, or I will draw a little triangle, represent our rise and our run. Okay. Again, we always start from left to right, so we're going to start here. We're going to go down 1, 2, 3, 4, 5, 6, 7 spots. So that's a -7 on our rise, and 1, 2, 3, 4, 5, 6, 7, 8, 9, and a +9 on our run. So our slope is rise over run. Rise being -7, run being 9. This is in simplest form, so this will be our slope. Now remember, this one's going down, so that's why we have a negative slope, and that's one thing that represents it there. Now let's take a look. The other thing that we would need if we're going to use graphic form is our y-intercept, and so our y-intercept is right there. Well, we know that the x value is 0, but we're not sure what our y value is. 1 is right there, 0 is right there, and it's somewhere between, -1. It's somewhere between 0 and -1. Looks pretty close to -0.5, but because it's not actually on a nice point there, or a nice grid line, it's really tough to see what is exactly our y-intercept. Okay, and so our y-intercept is, we could say, approximately -1/2, roughly. We're not sure exactly what it is. Now, that becomes a problem. As the y-intercept is not a nice number, we can't find it exactly, we're going to need to use a point, okay, and the slope with the slope formula to create an equation. Okay, so this is what we're going to do. We're going to use that with the slope formula. And remember that our slope formula is m is equal to y2 minus y1 over x2 minus x1. What we have here is we have the slope, and remember the slope, y2 and x2 are one point that we have, and y1 and x1 are another point that we have. Okay, so we're going to use this to come up with a nice little equation. Now, a couple things that we want to know. First thing, we have m is going to be our slope. Okay, so let's just put this down here in a little bit of order here. M is our slope. We're going to have x2 and y2 is going to be what we're going to call a generic point that's on the graph, which we always represent just as x and y. Okay, so remember, this is like the x and y that we're trying to solve for, or that we're unsure. If we put an x value, we get a y. That's this point right here. Okay, that's the point that we're trying to solve for. And x1 and y1 is some known point on the graph. Okay, so it's some known point on the graph. So we're going to actually end up changing the x and the x2 and y2 to x and y, but we're going to leave these as x1 and y1. Now, what we're going to do here is we're going to rearrange the formula so that there's no dividing or no fraction. and all the pieces are on the same level. And this will be done by multiplying the denominator to both sides. Okay, I'm going to multiply the denominator. So we're going to do a little bit of algebra here. What I'm going to do, pretend these are in brackets here. I'm going to multiply both sides by the bottom. Okay, and if I multiply both sides by the bottom, it'll cancel out, and it's going to pop up on the other side. And so what we're going to have is we're going to have m, and then we're going to multiply it by x2 minus x1, which we can do, is equal to y2 minus y1. Okay, they're all on the same level. And now the last little thing that I'm going to do is I'm just going to replace the x2 and the y2 with our x and our y, and I'm going to rearrange it a little bit so that the y is on the other side. So we're going to say that y minus y1 is equal to m x minus x1. And this right here is our slope point form. Okay, and I'm just going to explain it in a little bit here. Okay, m is again our slope. That's always our slope. Okay, so that's always what our slope is. The x and the y is every point on the graph or the function. And we're going to replace the y1 and the x1 y1 with a known point on the graph. So when we're coming up with this with an equation for it, we're going to replace the slope, and we're going to replace x1 and y1 with some point that we know on the graph, and that's going to create a nice equation that we can then use to solve, or that we can use to describe what our graph in fact is. Okay, so we're going to be using this form right here in creating an expression or an equation to describe our graph.